welcome. So my name is Saf, for the new guys. Alan Smith here, and I started this group because we wanted to make sure that we had an option for a little bit more advanced topics, more beyond the this is a loop and this is a case structure. And we also started streaming the session. So we have people that connect from Japan, Australia, the different places in the US, Europe, and then these sessions also get recorded then, and we can watch them later.
Yeah, new people, world, new people.
Yeah, exactly. So if you want to present, please do let me know. If there's something that you want to see, but you don't want to present, also you can let me know and I can try to find someone. That's what happened with David today for the project provider.
I got volunteer.
Yeah. Did somebody ask for project provider?
I would amend your request, and I would say if you have something you want to present or something you want to see presented, post to our forum.
Oh yeah, go to the forums. One thing that happened with the forums, when I moved from the community to the forums, you still have your subscription, but you have to go back and re-register for emails notifications. So you're not getting notifications because you're not re-registered for notifications.
It's not because we don't like you.
Yeah, exactly. It's not because we don't like you. All right, so today, well, thank you to NI for sponsoring food. Yeah, thank you, NI. The place, too. And then thank you to SixClear because they continue to sponsor the Join Me and also editing the videos afterwards and posting them. And we have two presenters today. So Nate Mohering is going to be presenting on unit testing. And not that, had anything to do with the fact that I select the topics, right? I kind of like unit testing a little bit. So Nate asked if he could present, so he's going to be presenting on that, and then we're going to have our lovely David Ladocheta here present on the project provider. And, oh, by the way, if you suggest a name for your presentation, I'm going to use it. So if you put a click and bait name, I'll use the click and bait name. All right, Nate, anything else I need to say before I pass it to you? I don't think so. You ready?
I am ready, Fab.
Okay, can everybody hear Nate? Yeah? All right. Oh, there you go. We got a camera.
All right, guys. Well, I'm happy to be here. Actually, I wish I was there in Austin. I was planning to come to Austin and had too many things pop up at the last minute. I'm going to switch my slide to a survey. I have a few interactive slides here, and I'll do a little more introductions while we're doing the first interaction. But this is using Poll Everywhere, and if you send a text to this Nate Mohering 863 to 223, I'm sorry, send the text to 22333 with the phrase Nate Mohering 863, and then send another text with an answer, either A, B, C, or D. We'll get live results here. Or you can just go on your browser on your smartphone and do that URL you see at the top. So, why are you listening to this presentation? Because I keep hearing about writing unit tests, and I want to know how to get started. Because I love writing unit tests and want to do it even better. I heard there was free food, or I'm waiting for the next presenter.
That was not the next presenter who.
So while those results are coming in, I'll just say a little bit more. Again, my name is Nate Mohering, and I'm presenting from wonderful Waco, just a couple hours north of you. I put together this presentation on unit testing in LabVIEW because I feel like I have a little bit of experience in the area and can help out those who are maybe a little bit newer to writing unit tests in LabVIEW. And I know it's a topic that Fabiola really loves, so I figured I would take advantage of it. Okay, well, that's pretty good. So it looks like more than half are writing unit tests, and we want to get better. Oops, balancing out some more. Okay, so glad you're here and look forward to getting comments and feedback from you on this presentation. I'm going to be posting all of it to the LAF forum when we're done here in a couple of days, probably. First, I'm just going to talk very generally about unit testing, but I'll keep that brief because I believe that most of us kind of know more or less about unit testing, and then go into a few more advanced tricks that I find very useful. So basic question, why spend the time unit testing? And Fabiola has a great presentation on this I linked at the bottom, Save Time and Money with Unit Testing, where she gave a real-world use a story of a company that provided medication and was, regulated by the FDA, and a very seemingly simple SubVI ended up costing them a lot of money, and that could have been avoided by doing adequate unit testing. So finding bugs early is the most important thing about unit testing. This little graphic here, highly scientific, just kind of illustrates that the further that a bug is detected in the life cycle of a piece of software, the more expensive it is to address that bug. And they say a factor of 10 for each of these phases of that software life cycle. And so ideally, the developer would find all the bugs before it ever even gets out to its first deployment. And unit testing is our first line of defense to do that. Also, how do you know that you're meeting your functional requirements, especially if you actually have formal requirements traceability? You need a way to develop 2 requirements and then show that you meet those requirements. And then there's such a nice peace of mind that is provided to you whenever you change, especially someone else's code that you're not quite as familiar with. If you can just rerun a battery of unit tests and verify that you did not cause any regressions in that change that you've made, you can really go to sleep a lot easier at night feeling that way. A side benefit of writing unit tests is that code that is written to be testable is also easier to read and more decoupled. And I don't remember where this adage comes from, but basically we want to write our code to be write it once and read it many times. And so therefore it actually pays dividends to write your code in an easy to read way, because both your future self as well as your colleagues are likely going to be reading that code many times in the future. So make that as efficient as possible, optimized for reading. And then also, when we decouple our code, of course, we get a higher likelihood of being able to reuse more of that code in other applications. And then finally, unit tests also provide a form of functional examples for other developers. If they're trying to reuse your library or SubVI, they can look at the unit tests that you've written and very quickly get a good idea of how to use that. So any comments at this point? Feel free to, I guess we do that through the chat, huh, Fabiola?
No. So I had a comment. Yeah, if anybody from remotely wants to put something on the chat, let me know and I'll relay it to Nate. The comment I was going to make is also unit test is a way for you to be the first user of your API. And that means that once you start using your own functions, you realize whether you have the input you needed, the outputs, and sometimes you even have to add documentation just because yourself are having trouble figuring out. So making it where you have to suffer through your API first also will make it a better API for others. Any other comments?
That's a great point.
No other comments? No, everybody's busy eating.
All right, sounds good. All right, so this is an interesting question. What % of your total coding time do you think should be spent writing unit tests? So if you've already joined the poll last time, you don't need to do that setup part. You just send A, B, C, or D to the same number. All right, so somewhere between 25 and 50% it looks like, and I would tend to go for 50% as well. Not necessarily that I always do that, but again, the more time you put in up front finding those bugs, the happier your team is going to be, the happier your boss is going to be. Ultimately, the better your bottom line profit is going to be.
There's a comment.
Okay.
How influence our answers to something like this is the definition of a unit.
Yeah, he says that something that will influence the answers is the definition of a unit.
Okay, I am going to talk a little bit about what an ideal unit is in just a minute. I think a unit is a little bit variable, but it's kind of the smallest atomic piece of code that has a purpose. And of course, you can ramp up your units, what that means, all the way up until some point of a built application. So yes, you can have unit tests that test your interface of a larger library. I think all of that can be considered unit testing.
Yeah, the way Roy Oshervor, the guy that wrote the art of unit testing, he defines it as a unit of work. So, for example, it could be a transaction, it could be a method, it could be a library, a whole set of libraries, it could be a group of libraries. So, a unit of work. So, basically, what is the action that you're testing?
Class or an actor.
Yeah.
Is it fair to say it's the task that you're trying to accomplish?
Yeah, it could be the task, and then you just have to be careful about getting into integration, right?
Right.
So, for example, if you're working with a database, obviously a query could be a unit test, but the fact that you're using the database makes it an integration test, because the database is not part of your application. So if you change the way you're writing your code as to your testing, if you're formatting the query correctly, that can be a unit test. Does that make sense?
So I'm going to talk just a little bit about kind of what is testable code. I have a simple front panel here that is literally just to create SubVI around an add primitive. And I think this is kind of your ideal piece of testable code. Not that you would actually do this in real life, but all inputs and outputs are on the connector pane. They're clearly visible on the front panel. They're all, ideally, the inputs and outputs would be basic data types, although we realize that's not always going to be the case. No use of references, take advantage of data flow. No global variables on the diagram. That includes LabVIEW globals, functional globals, or action engines. No behind-the-scenes stuff with VI server. The result, the output, should always be deterministic, so not a function of time or randomness or some other variability. And the unit has a limited responsibility. So obviously we know that SRP can be, single responsibility principle can be applied at class level as well. But taking that concept to a unit under test as well. I first started writing unit tests sometime around LabVIEW 6. And at the time, the unit test framework did not exist. And I created something with scripting that basically you pointed to a VI and it would create a new VI that would basically feed in a bunch of inputs, compare the outputs to a bunch of expected outputs, very similar to what unit test does, but it did it all in LabVIEW instead of a spreadsheet. And that was my first experience with kind of the negative effects of using references or global variables within your code, was that I had to, in that test framework that I was writing, add in additional code to basically discover things like global variables and LabVIEW globals, and then make those available to you, the person writing the test, to populate those values as well, because they're really like hidden inputs and outputs to your unit under test.
There's a question. Mark is asking, why not references or FGVs?
Well, a functional global variable really is just a global variable. So I don't think that needs to be, I mean, it has additional code in it as well, so you would need unit tests on your FGV for sure, but if the code you're testing has FGVs in it, then the state of those functional global variables has to be managed as part of each call, each test case. So I'm going to show examples where, I mean, obviously we do use these things in our code, and I'm going to show examples of how to test those things. But again, I'm just stating kind of the ideal, like for easy, simplistic testing and most readable code.
Okay, so for the action engine, you're saying that an action engine inside the code that is being tested, or that an action engine itself is not ideal code for testability?
Saying that having action engines within the unit that you're testing makes it more difficult to test.
But if the unit is an action engine and has clear inputs and outputs in the connector pane,
then yes, that is testable.
All right. Thank you.
And again, the problem with references is just that, similar to global variables, that the meaning of those references, the data that they represent, was populated somewhere outside of the scope of this particular unit that you're trying to test. So it's just more to manage.
Yeah,
so I'm going
on the same line is the having a cluster Soros Rex, like a huge cluster on the input. That's also, especially if you're just unbundling one or two things, because that means you don't know what is it that you have to provide for the entire cluster, right?
Yeah, that's a good point. So I'm going to expound a little bit more on the limited responsibility, and then we'll get into some fun feature stuff. So when we assign more than one responsibility to the unit that's being tested, I'm just calling it a SubVI, then it makes that SubVI less reusable and harder to test. And so just a very simple example is, conceptually, you might think that parsing a config file is, a unit unto itself, and maybe you have tests at that level. But if you think about it, you can break that down into a series of steps and then test each of those steps independently. So for example, loading the file into memory, if it's just an ASCII file, then that's kind of trivial. But if it's an Excel file or any kind of formatted text file, then there's multiple steps required to do that, or other libraries even that you might be calling. Parsing the file into reusable data structures. These are like data structures that are not necessarily application specific, but can be ingested by your application. That way you can reuse this file format in multiple applications. Validating those data structures, generating a report to the user about, were there warnings or errors that occurred while parsing this config file. And then your applications, of course, would be loading those into their own data stores, perhaps just wrapping them. So again, by decomposing that one unit into 5 units potentially, then you can write more comprehensive unit tests, and each unit test is easier to write. Okay, so a brief survey of current tools that are available for unit testing in current gen. Unit test framework made by NI. Unfortunately, NI doesn't have any plans to support that going forward. And personally, my experience with unit test framework is that it's too slow and buggy to be very efficient for my use. Fabiola talks about other value that unit test framework provides, and that's fine if you need it. JKI VI tester, JKI Karaya. And then as we look forward to the future about next gen, this is some speculation, but it's also based on some feedback I've received from JKI and NI and Compose Systems. It seems most likely to me that JKI Karaya would be supported first because it requires the least amount of tech implementation within next gen compared to the other systems. Compose Systems, which is kind of in design phase by John McBee, is taking a different approach. He wants to do a test-driven development architecture workflow for developers, and is hoping to have that available sometime with NextGen as kind of like the first third-party provider of a unit test system. I don't know what the status is of that. And then my expectation is that JKI VI tester will come along as soon as possible. JKI VI tester, I'm getting a lot of talk on the line. Can people mute their lines, please? Thanks. The cat is mine, unfortunately. My 3-year-old son just came in, so the cat came in after him. Let me.
They are great co-reviewers, by the way, Nate.
I know you said.
Oh, come on.
Sorry, Nate. I was trying to see if it would still let you talk. You can talk again.
I think you muted him.
I muted everyone but included him, which is annoying because he's the presenter.
And now he cannot talk.
It should work again.
He has it, yeah.
Oh, now we go.
There we go.
There we go.
Sorry.
Okay.
The cat.
The best laid plans, you know.
Yeah. There you go.
Okay. So we have another poll. I'm interested to know what unit test tools you use, or if you use a third-party tool, or if you have your own homegrown tool.
Where's S, none of the above? What is unit test?
So I'm gonna take this opportunity to do a plug. DQMH 4.0, which is in beta right now. If you're using DQMH, the DQMH 4.0 has a new feature to create unit tests for your request. We made it tool agnostic, so it creates the setup, the unit under test, and the teardown, and then you can choose if you use unit test framework, JKI tester, your own flavor. Anyhow, sorry.
Cool.
Nate.
You're allowed. All right, unit test framework is tied for the lead, huh? I did not expect that.
Me neither.
What are you talking about? They don't use it there, except for Paul's team. All right, so some of my presentation is VI tester specific. Hope you can bear with that. 33% of you can. So one of the things that Jim Kring says is nice about VI tester is that you're writing your tests in G, and us being G developers, that's what we enjoy, that's what we're good at. I think this is a very valid point. That was one of the barriers, I think, to me adopting unit test framework was that you really had to kind of switch your environment into the UTF editor, which is basically like a very poor version editor of Excel. But anyway, I enjoy writing unit tests in G. It's a free tool. It's actually open source on GitHub. So if you want to make improvements to it, go right ahead on your own fork, that is. And when you create a unit test with VI tester, you're really creating a class that contains several methods. The actual tests themselves are the test methods, and they have to contain the word test in the file name. Otherwise, the VI tester GUI, the thing that runs the tests, will skip over them. So they just kind of, you can create other methods, but they kind of like are private. They don't get picked up by the tester. So those test classes are actually called test cases, and then you can also do some dynamic aggregation of test cases using a facility called test suites. I personally don't use test suites because basically I'm just interested in running every test case in my repo every time. I don't need to like down select for certain projects or whatever. In order to discover the test cases, I mean, you could use a naming convention to do that. Wanted to highlight this VILib utility here. I don't know if this is on the palette anywhere, but it allows you to inspect the hierarchy of a class without actually loading that class into memory. So I assume it's looking at the XML. So this is how you can look through your repo very quickly and just identify the test suites and the test cases out of all the classes in your repo. And then they have a couple of APIs. One is for when you're writing your test methods, doing common types of comparisons, and then associated reporting with those results. And then another API for actually running your tests programmatically. So very briefly, go ahead.
Sorry, there's a question from Russell. Like, did you try use user-defined test VIs with the unit test framework?
Absolutely.
LabVIEW with LabVIEW.
Absolutely. And what I found was I was doing that so often that the value added by unit test framework just wasn't there.
Agreed. And then the other thing that my other pet peeve with that one is that the default template starts with the test passing. And for everyone, if you're creating unit tests, the default should be fail. Otherwise, you don't have the I'm creating code to make things pass. Anyway.
What do you mean by that? You mean that there's just no inputs and outputs by default if you run it?
So yeah, so if you create a custom user-defined unit test with the
for user-defined, okay.
Yeah, user-defined with a unit test framework, by default it passes. All right, sorry.
No problem. So I'm going to briefly show kind of the common steps that I go through when I'm creating a new test. VI tester new test case. Again, this is after you install it through VIPM. This is a common tripping point when you first start using VI tester, is that it's asking you for a folder name. It says file name, but it's really going to create a folder and also create your class, your test case class with this name as well. Let me just get out of that and hit OK. So here's my new test case that it created for me. Still working apparently. This is one of my frustrations with VI tester. As few as they are, it does take a while to kind of get up and running with a new test case. I don't know why my laptop seems to be running very slowly right now.
Because of Join Me.
All right, well, I will skip this step because I'm afraid this might take a while. I'm hoping that many of you have created one before. Basically, it creates a test case LV class. It creates a VIT file, which you can use as a starting point for new tests. In reality, I don't find that very useful. I just do a save as and rename it to my first test, and make sure you take the T off of it because the test executive will not pick up VIT files when it's looking for test methods. And there's a dummy unit under test that you always have to delete, and then unlink it from the template method. And then there's also a setup and teardown VI, which we'll go into more description in a few minutes. So that's kind of like the bare minimum for getting started with a new test case. I have a project here that we're going to go through with some pre-made examples. So
that sounds like a lot of work.
It is quite a bit of clicking to get started. One of the things that I'm going to reveal here in a minute is that if you are using project templates, you can build kind of boilerplate test case classes into your project templates so that after you've instantiated a new whatever, you kind of just have a place to start populating tests, and that has saved me so much time and frustration.
That's what I was going to say too, is that you can create your own unit test class template and then just do a copy from that instead of going through the menu from JKI.
Exactly.
And that way you already don't have the VIT.
So I mentioned that the APIs for doing the basic comparisons, these test case methods here, have built-in reporting options. And one thing that I consider a bug currently is that if you have multiple comparisons within a single test method, then what gets reported to the log file when you're doing automated runs is either the first fail message or the last success message. So it makes sense to me that it should be building up a list of all the successes and fails within the test, but it does not do that. I think that it's probably good test theory to not do multiple test cases in a single test method, but in practice, it just seems so much more efficient to go ahead and check for a number of things, in a row. Or conversely, you could do what you kind of had to do with the custom tests within unit test framework, which is kind of like aggregate all of your comparisons into a single comparison check. But then you really kind of lose the information about what failed within the test. Any comments on this? This is like a pro tip here. You have to kind of think about which comparison is most important to you and put that last, so that if that's the one that fails, that's the one you look at in the report.
I tend to do a single comparison BI per test because of what you mentioned. It also makes it easier to name your BI test, your test, because then you can say verify animal likes to eat is the name of one test, and verify eating makes animal happy is another test. If later on, for whatever reason, you have to make some modifications to one of those two, it's easier to find where that test is by the name of the BI.
Yeah, I agree with you, but it just there's a number of times when you're like, I need to check this and this are true in order for this test to be valid in that case.
You use the check from the API that it says pass is true, and you do an and on your end.
Right, but then if it fails, you don't know which one failed.
So we have another question here. Do you use the custom message to describe what happened in the test or what the test checks?
I have kind of flip-flopped on that over time, and I don't know that there is a right answer necessarily. What I've settled on here and what I've been doing most recently is putting the intent of the test, and then if the intent was passed or failed.
Anybody else? Yeah, there's a comment here.
I have a question. You ran into some performance issues on VI tester, just created a new one. What's the most number of unit tests you have on a project, and do you have performance problems having a large number of unit tests?
Did you hear, or do I have to repeat?
I heard. I don't really execute the tests out of the project environment. Basically, I will open individual tests, the test case class, work on those independently, and that they'll have anywhere between a handful and 100 tests within that test case class. And in that scenario, I don't have any performance problems. The editor is responsive. The tests run super fast. Whereas a unit test framework, similar set of tests would take like an hour to run. Here you're talking about seconds. It's just super fast. But again, I don't run tests directly out of the project environment. I know that the VI tester is supposed to be able to find all the test cases in your project, and my experience has been that behavior is kind of buggy and it's also kind of slow. So I don't worry about that. Instead, we have continuous integration that is running on commit every unit test that we find in the repo.
So if I understand correctly, your main project has no unit tests in the actual project. You'll just create them one at a time, and they'll be standalone. They can
be in the project for convenience. I just don't try to run them from the project environment like that.
Okay, so you'll still have one project file that includes your project and all the unit tests.
Maybe. Not always. I mean, they don't really need to be in the project.
I like to include them in the project as a reminder of you have to run them, especially when you have multiple developers, because some developers might forget about it. So just having the unit test.
Yeah, that's why I say it's for convenience, but it's not out of necessity.
Do you ever have to actually run the test instead of after every commit, have to batches of commits and it's taking too long?
Our continuous integration will skip commits or change sets if it gets behind, but it does that. The only time it would get behind is as a result of builds, not of unit tests, because the unit tests don't take more than like a few minutes to run, and that's for 1,000. I don't know how many tests we have. A lot of tests.
Personally, has that question.
Yeah, just real quick, are you going to be giving any recommendations on how to organize your tests on disk relative to your source?
I don't, and that's another thing that I've kind of flip-flopped back and forth in time, but my current position is I like to have all the unit tests as close to the thing they're testing as possible, for the same reason that Fabiola said have them in your project. It's just so that they're easy to discover, and the developer knows that they exist, so they should probably be updated if he's changing the code, or at least be rerun before he commits.
But do you have them next to the VIs that they test?
So usually I have like my folder full of methods, and then at the same level I have my folder full of unit tests.
So we do the same thing. We have our libraries, and then at the same level of the libraries we have the unit tests. And the reason for that is it's easier when you're building a package to just
I'll be right back,
keep the unit test folder. Yeah, okay. So I guess we continue. She said I'll be right back. Because when you go and build a package and you say source, if they were next to the VI, you would have to go individually and uncheck them. Where if you have them in a folder that's called unit test and it's at the higher level, they either don't even show, or if they show, you just select that folder and say don't include.
It also helps enforce the composition, where like this unit test is for this set of methods, not for the combination of these different.
Yes.
What do you do if you want to give the code to a customer? Do you always then commit to giving the beta test as well, or do you want to strip those out?
So that's why also if it's a separate folder, you can make that decision a lot easier.
You have to just delete like 50 unit test folders. Or have some automated.
No. You have, so if for a project, you have a project, you have the libraries, and you have unit tests.
Okay.
So the folder unit tests you just don't include. And the unit tests within them are separated by the library name.
Okay.
So you've got parallel now.
Yeah. Parallel directory structure, so you can easily remove it, and you know who goes with whom.
I tend to do that, where I've done that, I've done it at the package level. I know this thing is a discrete thing that I'm going to distribute.
Yeah.
So it may not be the whole application.
Yeah, no, we never have the whole application. We build the all the dependencies into packages or pack libraries. Are you back? Nate, you're back.
Yes, I'm back. Sorry, I didn't realize you were still stalling for me. Thank you very much. All right. So I mentioned briefly that in addition to the test methods, there's also a setup and teardown method. These are optional. You can delete them if you're not going to use them, but they are very useful, so I typically leave them there even if I'm not going to use them immediately. So let me show you my project that we're going to be walking through a little bit. I have an animal class, which is the parent class, an animal test case class, which has a few test methods in it, and also the setup and teardown. And then I've got some subfolders for fox class, rabbit, or just other types of animals, and then their associated test cases. So the setup and teardown is where you can do work that you need to do before or after every test method in your test case. So this is also where I find most useful to manage the global data that we're talking about earlier. Unfortunately, there's a lot of code that is not written to be testable, or some code is just inherently always going to have references and there's nothing you can do about it. But by creating these, or by utilizing these setup and teardown methods, you can basically kind of re-implement the minimum infrastructure necessary out of your application in order to create, kind of that realistic environment for that test method to do what it's supposed to do. So I've written rather large and complex setup methods because, I'm working on arrays of references of different data types and, different in-memory databases and all that kind of stuff. And it really, it pushes you closer and closer to full-up system integration testing without actually having to deploy to a live system that has, all the necessary pieces running on, servers or whatnot. So I really think it's valuable to spend a lot of time thinking about how you can test as much code as possible in the unit test environment, because it's so rapid to write and to run, and you don't have to go through a build process to actually get to testing those things.
Is there a way to designate setup and teardown for a batch of tests?
That's what the test suite is for, and test suite has its very synonymous types of methods called new and cleanup that do exactly what you just requested. Again, I haven't used test suites, but I'm aware that's what they're intended for.
I have used them, and they violate one rule of unit tests. Unit tests have to be easy, fast to create, right? And once you start getting into the test suite, there's a whole special way of assembling the classes in order to make it that is not straightforward or fast or easy. So I stay away from the test.
But there is
All right.
a way fast without test suite.
Okay, wait. Darren is saying that there's a way.
So when you create a new test case class, it automatically creates the setup and teardown for you. There's also overrides called global setup and global teardown that it doesn't create for you. But if you right-click on the class and do override, you can make a global setup and a global teardown, and that'll run one VI before all of the methods in that test case.
Do you hear that?
Oh, cool. I did not know that.
You can have another sandwich.
That was called global setup, global teardown?
Yeah, global setup and global teardown, and they're overrides. So I guess you can show it now. You have the code open. Lee?
No, I'm running behind on time here, so we're going to move along. So getting to my power tips, perhaps these are more common than I realized, but these are things practices that I found have saved me a whole lot of time and really improved my test coverage. So if we use the concept of a friend in a class, then you can declare the test case class to be a friend of the class that you are testing. So in this case, we're kind of talking about the entire class as being your unit. And then that allows you to, you can specify methods within that class that you're testing as community scope. And that allows your test class to call directly into what would normally be considered private data in order to bypass basically a lot of complex logic that you might need to put into either your setup or in your test method itself. Particularly if you have a class that kind of implements a little bit of a state machine, and you need to kind of work your, do a series of inputs and actions in order to get your class into a particular state. If instead you just create a community method that allows you to poke that state, whatever it is, then it maintains encapsulation, but allows you to simplify your life and reduce development time significantly. I linked here a presentation I gave 3 or 4 years ago, thoughts on accessor methods, where I go into a lot of detail about like what is good accessor methods, and in that presentation I speak pretty strongly about if you ever find yourself creating a method called write something, then think about whether or not your application really needs it, because you're automatically bypassing encapsulation when you do that. But for the purposes of creating really comprehensive unit tests, I think this is a magic bullet. It's like saves you so much time, increases your test coverage. So again, the key here is literally this little blue key that says that only the friend classes are allowed to call this method. Any thoughts on that?
We love the pun.
Mm-hmm. And again, this is where you can use project templates to help you get into this configuration faster, because most of your developers, if you have junior developers underneath you, they're not going to think to use this method or this feature for this purpose. But if you're creating templates for them, then that can be kind of an out of the box thing.
Have you had along when you declare a friend?
No.
I seem to recall having issues with, I declared something a friend and I can't find my friend, and so now I'm cranky when I try to do a build.
No, I have not had that issue.
It should never reference the friend. The friend may reference the original class, but it shouldn't go the other way, right?
So the simple declaration is,
Yeah.
okay, I must have been
Right.
doing something else.
I think I had the same issue, so it might also be something that got fixed
That's
in
true.
newer LabVIEW.
That's true, it's been a while.
I have stayed away from communities.
So this is looking at our first test method here. I was kind of like grasping for straws about what to create as an academic example until I started thinking about this animal class in terms of a game like Talking Tom. So in this test method, I am poking the state that I want to exercise inside of the unit under test. And when we have this test harness like this, the longer the harness gets, the harder it is for another reader to identify what is this thing actually testing, especially when the method names don't match. So here sometimes I'll add a comment, say like, out of convenience, this is what we're actually trying to test in this test method. So looking at the test method, you can see what it's doing is looking at the current state, and if we're called to sleep and we're tired, then we'll do some sleep logic. But if we're not tired, then we're just going to stay in whatever state we're in, and we're going to say, well, we're not going to sleep any. We slept 0 hours. If we are tired, then there's a special random function we'll get to in a minute, and we're just going to kind of randomize how long we sleep. And if we slept for some arbitrary amount of time, again, forgive the gross example nature of this, but then we're going to say, okay, now we're hungry because we've been asleep for so long. But if we didn't sleep long enough, then we're going to remain in the tired state. So very simple state machine, but without having a right state method, you can imagine there might be a series of actions that I would need to take in order to get it into the happy state to exercise this case, or conversely, the tired state. Oops. So the flip side of this, another test, the same harness. This time I'm writing in a tired state before I call the sleep method to get to the other case of that case structure. And again, normally it would never make sense by rules of encapsulation to allow to have a public method called write state. That would just allow anybody to do anything with your library. All right, well, if there's no questions or comments on that, friends are great. Now let's talk about that random function. When writing unit tests, if your unit under test relies on any inputs or outputs, such as time or hardware I/O, or maybe even OS calls, then in order to make that thing testable, you might need to stub out those function calls or those primitives and inject your own value at time of test. And so you can come up with different ways to do that. A couple of them might be using dependency injection, and when you're constructing your application or your unit under test, you inject the simulator class instead of the real class. I think a lot of cases that are very generic, you don't want to have all these extra wires running around of the actual object that you are injecting. So globals are a good option. I think they're also highly performant, and they don't clutter the diagram. So I've created a random number library to replace the random primitive. And inside of that library, I have a private global variable. And all that does is it restricts the access of this global to these 3 members of the library. So it's kind of like global with limited scope. I have the standard get random number function, which is going to just look at the global, did the unit test tell me that I should be using the specified input, or if not, just return the standard random function result. All right, so we looked at a case where we retired, but we don't know if we're going to be hitting, oops, wrong method. Don't know if we're going to be hitting a greater than 8 or a less than 8 condition if we just use a true random value. And so we can never write a unit test that really verifies this case or these outputs without making this a known input. So I have at the beginning of my test method a set random to 0.1, and it's going to set that global flag, and it's going to set that global variable saying this is the value I'm going to use. I'm not going to actually use a real random value. And then in here we say if use input is true, then return that random input. And then we fall into the less than 8 case, we return tired, and we verify that. Or my other test method that tests the case where we did get enough sleep, I just poke the 0.8, which kind of tests that borderline condition. And now I have a repeatable test. I applied this in production recently. I had a PID algorithm that the library, it's basically the NIPID library. It gives you the ability to provide the DT between executions. And you can use that for your unit tests, but I have an abstraction layer on top of that in order to be able to swap out various control algorithms. And because of that abstraction layer, I lost my DT input. And so it instead was doing a real-time DT calculation on each call from my test framework. And it would work for like 2 months. And then within 1 week, I would have 2 or 3 failures. And that's because our continuous integration is running on a VM host, or a virtual machine host that's got, I don't know how many other bots on it. And occasionally there's going to be contention, and that DT will directly affect the outputs of your control algorithm. So I applied this same principle with a slightly different set of code, but the same idea, so that my unit tests now inject what the system clock time is instead of just reading the system clock time, the tick count. And then that way my results coming out of this PID algorithm are, extremely deterministic. So that has alleviated a lot of heartburn, because every time our unit tests fail, there's like, oh no, something's broken, go fix it. So, any comments on stubbing? Any other success stories or words of wisdom?
I had done it with class hierarchy, not like this.
All right, class hierarchy is next.
Yeah.
Okay, another I think feature of VI Tester, although not necessarily specific, but is the idea that you can create a class hierarchy that mimics your actual production code hierarchy. So we're going to look at some examples of that. Oh, too early for that one. All right, so let's look at the setup code for, let's look at the rabbit class first. Just to give you a little bit more context of my example here, the animal class has an attribute that's a user event that will be fired whenever the speak method is called. And there's an attribute, so if we look at the speak method there, so the speak method pulls out what it's going to say and fires that user event. And so a child class can poke into that says attribute, what's up, in this case for a rabbit. And so in our test case, in the setup method, we're going to construct, so this is calling the constructor we just looked at, a rabbit object. And then I had to create a little bit of a helper VI here because I want to store that test object into the parent test animal test case. So normally we would just do this, create an animal, store it into the private data. Now that private data is one layer removed, so I have to create a public accessor for it and poke it in that way. And then we're going to go look at the test speak method of Rabbit. And so in test speak, we're going to use an accessor to get that the object that we're testing out. And then we're using an accessor to get the user event out and register for that user event. Be sure that happens before we call our unit or test. And then we call the speak method, which of course fires that user event. And our event handler is listening for that user event to occur. If it doesn't occur within 1 second, then we generate an error. Oops, I actually didn't even wire the error output of that. I'll correct that. But most importantly is we're comparing, did we get what we thought we would get? And so what's kind of cool about this is that we're able to enforce that a child class called Rabbit, in this case, has a specific behavior, even though Rabbit did not override speak. You see in Rabbit class, I didn't have to create a custom method called speak. It's still using the parent speak, but I was able to verify its unique behavior by overriding that test speak method within the test Rabbit class. And then I have one more example which is kind of similar. If we look at the the Fox speak method. So in this case, I want to enforce a unique behavior of Fox by actually overriding the speak method. And this is inspired by a children's song called What Does the Fox Say? Nobody knows what the fox says. So if they call speak, we're just going to return an error, and we're not going to say anything. So in this case, in my Fox test case, I also have a test speak override. But rather than even bothering with the event handler, again, I'm going to pull out the test object, call this speak method, and then verify that it came back as an error. So this is more of the traditional, like one-for-one. You override a method, you create an override test case to handle it, or a test method to handle it. But that's not always necessary. One more thing that is a pro tip here. If you want to override setup methods, you can't actually do inheritance of test cases without doing one more step. It doesn't come for free. You create a test case, and then you go assign its inheritance through the dialog in the normal way. But it's going to say the class is broken. And the reason is because by default, the setup method and teardown method do not have dynamic dispatch on their input terminals. So you have to go in and mark those as dynamic dispatch so you can override those methods. And then you may have some supporting accessors to get access to the data stored in the parent test case. So I think this is pretty cool. It's a feature that lends itself well with VI Tester. What pro tip did you have, Fabiola?
No, that was it. That you could have the mimic of the hierarchy, and then the stuff was if you are testing, like let's say you have actual hardware and then the simulated version. I would use the simulated version so you don't have to do the integration with the hardware. So testing the child, basically. Does that make sense?
Yes, it does. All right, so I think this is our last slide here, finishing right about on time. What is the most interesting thing about this presentation, or what did you learn? This is an open-ended response.
Yeah, probably, Darren.
I was pretty sad about that.
Does VM tester have the capability of generating that parallel inheritance hierarchy?
No.
You have to map it yourself.
Yeah, you have to map it yourself.
That's a good question, while we're waiting.
No question.
No question, yeah. So for those of us who may have created a project and not had unit tests from the very beginning, or working with others that are doing that, how would you suggest going about, like, okay, you have the realization that you need unit tests, but do you just make the investment right away? It's like, okay, we got to go back and make unit tests for everything, or do you kind of go as is, or how do you kind of handle that?
Well, one piece of advice is start by testing public VIs.
Okay.
Yeah,
Like your API level, like
Yeah.
test that, and if it works, you at least have some confidence. Not at least how it failed, but it works.
Well, and realize you can do unit testing for probably other. So start writing those. So I broke this. I have to fix it. I fixed it. Here's the test. I fixed it.
Yeah, that'd be my second recommendation, as Alan said, is if you have to fix a bug, then take the time to write the unit test before you fix the bug. Make sure that it fails, then make the fix, and then make sure your unit test passes.
There's two ways of using unit tests. One is to document what convinced you that the code was well written, and the other one is to create a unit test in order to make them pass. So that applies to new code or bugs. So as soon as you get a bug, you say, okay, this is what I should be doing. You create a unit test to then make that unit test pass.
Because there's know this if you product test, you usually spend far more time testing the thing itself. You've got established legacy code. You know, you have some confidence, functional, test the stuff from the question. It seems to be that way you avoid. If you reach a point that's like, oh, this has been run so many times, it's been real life tested.
Yeah. Now, one thing is like on the question that Nate asked at the beginning with the percentages of testing. One thing that I realize is that the larger the code base, the less you're getting back from the unit test. Does that make sense? So it's not like your unit test goes in parallel with your code. There's a point that you get where you're not getting any return back. So you don't create unit tests for everything. You create unit tests for the public API, for the things that are failing, for when you are going to fix a bug, and that's when you're going to take the most, make the most out of it. If you start getting into doing too much unit tests, then it becomes a chore, and the return on investment is not that great. At least that's my experience, Nate. What do you think?
The rule I follow is as simple as this at a minimum. If I have to put in a few inputs on a front panel and hit the run button to see if it did what I wanted to do, then codify that into a unit test.
That's a way of documenting, this is what I had to do to convince myself.
Well, and for regression testing for the future.
So a little bit of a change. I wanted to ask you guys about types of tests that you write. How often do you find that you write tests like what you showed us versus writing tests that sweep over a range of inputs and expected outputs versus writing tests that characterize performance?
I think your mouse
Sorry.
moving, but I don't.
Yep.
Okay.
I do very few tests that do vector testing and do sweeps like that. I do mostly just discrete point testing your transition points, your transition in terms of logic or data types, you know.
I think unit tests are usually for performance. Right.
No, but you can do the vector testing is like if you are adding certain numbers, you might want to do it 0 to 100 or minus 100 to 100. I do those, and the ones where you want to exercise all the possible inputs. Now those that are testing for all the possible inputs, again, it's like do that when you're already used to doing unit tests. Don't try for your first project where you're doing unit testing to try to cover all the corner cases.
Yeah.
You're gonna get overwhelmed pretty quickly.
I found those most useful in refactoring,
Yeah.
especially code that deals with timestamps,
Ugh.
where you actually want to clear through as many possible timestamps as possible. For the old code, it applies to the new code as well. Make sure that it does indeed improve, work the same.
I couldn't hear all.
Go ahead.
I said I couldn't hear all of that. So if you're waiting for me to respond, I'm not.
No, I don't think it was a question. It was more of a comment.
All right. Well, guys, I got to run. Thank you for your time. Thanks for your comments. I regret that I didn't do just a straight up line by line response here because I can't make sense of the responses. But it was fun anyway to see it happen.
Quick question from Mark Lund. He's asking if there's an example project available with unit testing examples.
I don't know about that, but I will definitely post my slides and my little example project if that is interest to you. I'd like to get feedback from you guys when I post it up on the LAF page.
Yeah, I would like that.
I would think the tester ships is some kind of an example. No? Oh, I think I'm
It's got a cat and dog example it ships with.
Yeah. Well, thank you, Nate. Thank you
All right,
for
guys.
taking the time. Talk to you later.
Bye.